Hello everybody, these are the video notes for lesson 1.2. And we're going to title these notes Arithmetic Sequences. Arithmetic Sequences. Remember, everything that I'm writing, you are also writing down. Make sure that your name is at the top right of the paper. And you always want to keep your notes in the same section of your binder, in the notes section of the binder. Or if you have a folder for all of the notes, that's fine too. Okay. So we're going to write out a sequence. Let's say this sequence starts with the number 3. The very first term is 3. And then the next term is going to be 5, then 7, then 9, then 11, and so on. And that's the sequence. And now I want you to make a table on the left side here. Where it's n on the left side of the table and f of n on the right. N is going to represent the term number. So I'm going to write term number on the left here. Draw on these lines. And leave the first row of the table blank. And let's go 1, 2, 3, 4, like that. And now we can fill out this table based on the sequence. N is the term number. So when n is 1, that's the first term. That's the very first term in the sequence. That's right here. That's 3. I'm always going to use purple for my first term in these notes. I'm going to annotate that too. This 3 right here, that's the first term. And then the second term in the sequence is 5. The third term in the sequence is 7. The fourth term is 9. And we'll stop the table there for now. Now let's take a look at the sequence and figure out what the pattern is. So it starts at 3, and then it goes to 5, and then to 7, then to 9 and 11. It looks like it's going up by the same amount every time. All right, now I think to myself, how much every time? Well, this sequence is adding 2 every time. That's the pattern. And because it's adding the same amount every time, that's how I know it's an arithmetic sequence. So above the word arithmetic, or below it, wherever you have space, I want you to put a really big plus sign and a really big minus sign. So anytime you have a sequence where you're adding the same number between each term or subtracting the same number between each term, that's when it's considered an arithmetic sequence. And this amount that we're adding between each term, we call that the common difference. So I'm going to write here, the common difference in this sequence is equal to 2, because that's what's being added each time. All right. In this table, we're going to write out an expansion here, because I want you to see how we get to each of these numbers. And that's going to help us figure out how we get to the formula. The first term was 3. Okay, then to get to the second term, we know the second term is 5, but how do we get to 5? What's actually happening in the sequence is it starts with 3, and then we added 2 once. And that's how we got to 5. Okay, well, what about the third term? To get to this third term, we started with 3, and then we added 2 once, and then we added 2 twice. To get to the fourth term, we started with 3, then we added 2 once, twice, 3 times to get to this fourth term of 9. So that's like starting with 3, and then adding 2 once, adding 2 twice, adding 2 3 times. And we also know that when you're adding the same number over and over again, that's like multiplication. So this 3 plus 2, you can think of that as being 3 plus 2 times 1, because we added 2 once. This 3 plus 2 plus 2, you can think of this as being 3 plus 2 times 2, because we added 2 twice. This one here, you can think of this as 3 plus 2 times 3, because we added 2 3 times. And once we start thinking of the sequence like this, then we can actually figure out how to write a function for it. If we went out all the way to, say, term number 50, well, if we wanted to figure out how many times, or what the 50th number in the sequence would be, if we continue this pattern, we know we always start with 3, and then we would add 2 a whole bunch of times. But how many times would we add 2? Well, let's check the pattern we have. To get to the second term, we added 2 once. To get to the third term, we added 2 twice. To get to the fourth term, we added 2 3 times. So to get to whatever term number, we're adding 2 a certain number of times. And this number of times that we're adding 2 is 1 less than whatever the term number is. Right? What I mean by that is, to get to the fourth term, we added 2, 1 less than 4 times, 3 times. So if we want to figure out how to get to the 50th term, we would add 2, 1 less than 50. What's 1 less than 50? 49. So we would add 2 49 times, or 2 times 49. And that's how you would figure out what the 50th term in the sequence would be. In this case, 2 times 49 is 98. 98 plus 3 is 101. Okay. All right. With that in mind, there are 2 ways that you can write out an arithmetic sequence. The first is the recursive way. So let's write that out here, recursive. Now, recursive function, the way we'd write that out is, for this sequence, we have to say where it starts. So I would say f of 1 is equal to 3, because that's the first term in the sequence. And then I have to say what the pattern is. I would say the function, or the number in the sequence, is always equal to f of n minus 1 plus 2. Okay, now I'm going to annotate this so you can see what we're saying here. F of 1 equals 3. That's, in math, that's just saying that the first term is 3. So we say what the first term is. Then we say f of n is equal to f of n minus 1 means the previous term. And then this plus 2, why plus 2? Well, that's what the pattern was. That's what the common difference was. So what this is saying is, this sequence started at 3, and then each term is equal to whatever the previous term was, but plus 2. because it's adding 2 each time. That's recursive. The other way that you can write this function is using an explicit formula. So I'll draw a little border here. And let's say explicit formula, or an explicit equation. And you could think of this as for any n. Now remember, n was the term number. And for this, it's helpful to look at our example right here, right? To figure out what the 50th term was. Well, we took the first term and we added the common difference a certain number of times. And the number of times that we added the common difference is 1 less than whatever that term number is. So that's why the explicit formula for any n is we can say for f of n is equal to, in this case, I would say the first term plus the common difference n minus 1 times. Let's annotate. We have the first term and 2 is the common difference. And we add the common difference n minus 1 times, whatever term number it is. Let me show you 2 examples of this real quick. Recursive formula. So let's say I wanted to use the recursive formula. This is an example to find f of 5. This is the 5th term in the sequence. Okay, well, I know that the first term is 3, so f of 1 is equal to 3, and then f of n, so in this case n is 5, is equal to f of n minus 1. N minus 1 in this case is 5 minus 1, which is 4, and then plus 2, that's the common difference. Okay, so then I know that f of 5 is equal to, f of 4 is the 4th, this means the 4th term in the sequence. Well, check the table. What's the 4th term in the sequence? 9. 9 plus 2. So f of 5 is equal to 11. The 5th term in this sequence is 11. Let's do that same example using the explicit formula. So if I wanted f of 5 using this right here, it would be first term of 3 plus 2 times n minus 1. N is 5, remember, we're looking for the 5th term in the sequence. So 5 minus 1. So f of 5 is equal to 3 plus 2 times 5 minus 1 is 4. So f of 5, the 5th term in the sequence, is equal to 3 plus 2 times 4 is 8. 8 plus 3 is 11. 5th term in the sequence is 11. Same thing. Okay. So that is how you use recursive and explicit formulas for arithmetic sequences.